Okay, so today we are going to look into a problem linked list cycle. So we have given a head, the head of a linked list, and we have to determine if the linked list has a cycle in it. Now, what does it mean? It means a cycle if there is some node in the list that can be reached again when you continuously following the next pointer. Okay, so look at the example one. It says 3. When you go to the next pointer, it goes to the 2, and then it will go to 0, and then it will go to -4, and then again it comes to the 2, which was already we already uh, see that 3 is also pointing to 2, and 4 -4 is also pointing to 2. Okay, so in this example, the output should be true, and the explanation says there is a cycle in the linked list where the tail connects to the first node at 0 index, right? So to the first node, okay. And similarly here, 1 and 2. So head is given, that's contained 1 and 2 elements, and as you can see in the example, the 2 is again pointing to 1. So again the answer is true. And the third one is just a single node that doesn't have anything at all, so the next pointer is going to null. In that case it should return false. Okay, so there is no cycle in this linked list, right? And again, like the constraints and then a follow-up. Okay, so the follow-up says can you solve it using O1, like big O1, right? That means like the constant memories. Okay, this is very easy problem, and it has been asked in many companies, big companies. And again, like it's a very good question to work with. And there are multiple approaches to identify the cycle in a given linked list, right? You can use the set. In this one, we are not going to use set. We will solve it by constant memory. That means we are not going to use any data structure to hold the values for us, and then we can can do the lookup. So we will be solving these problems by simple approach, right? So let's look into that, how we can do that. All right, without using any space, right? So first thing first, I need to make sure that the head which I am going to work is not equal to null, and if it is equal to null, I am simply returning the false, that there is no cycle in this one, right? And the approach which we are going to take is the two pointers, right? So two pointer, one will be the slow pointer and the second one is the fast pointer. The slow pointers will move one step at a time and the fast pointers will go two step at a time. So I need the two pointers which gonna point to the same, the given head, and this is how I'm gonna define. So list node slow, and I would say its head, and list node fast. Okay, so fast will be one step ahead on this, so I'm gonna put the next one in here. Okay, the second thing is, now we will just going to move from one node to the other node, and in linked list we can do this while loop. Okay, so what we're gonna do is we're gonna do the while loop, right? And what we're gonna do in the while loop, we will just move our slow to the slow dot next, and fast to fast dot next dot next. All right, okay, and that the condition we will come later. But once we are done with this loop, right, there will be a point when my slow pointer, okay, will be equal to fast pointer, and that times, right, I would say, okay, I find like this like given linked list has a cycle in it. However, there will be a case when there will be no cycle. In that case, either my fast will be, because it's moving fast, will become null, or it will become null. So in that case also, right, we will be exiting from the while loop, and we can just compare at the time of when our loop breaks. We just need to make sure that the slow is not equal to fast. That will be it, right? But the main part we still have to complete is while when we're gonna break. So the first condition should be when my fast is equal to null. So when it is equal to null, I need to break. So I need to put making sure that whenever I'm looping through that, I need to make sure that my fast is not equal to null. And as you can see in the loop, we are doing the fast two steps, right? So fast is not equal to null. At the same time, my fast that next is also not equal to null. That's the two conditions I have to make sure that if I'm not going to make that fast dot next, we will be run. There is some use cases when we ran into the null pointer exception when we do this. So this is important. This too is important. And also when the slow and fast are pointing to the same value, same node, then that's also our breaking point, because we don't have to do any further processing, and this is exactly what we need to find. So we need to make sure while looping we have to check if slow is not equal to fast. If slow is equal to fast, that's our breaking point, and we find the cycle. So I think that will be it. So three conditions, right? I need to make sure that my fast is not equal to null, and my fast dot next is also not equal to null because the fast is moving faster, two steps. And also the slow is not equal to fast, because if slow is equal to fast, we already find the cycle, so we don't have to do anything else. All right, look at this. I think this very simple solution here. First thing, we are making sure that the head is not null. If it is null, we are saying false. There is no cycle in that. Then we are defining two pointers pointing to the same head. The slow one is pointing to the head. First, we are going to start with the next one. Okay. And then we are processing it while moving our pointers one slow one step, fast two steps, and and there will be a point where this processing when both will pointing to the same node, and that will be it. So let's run this and see how it goes. And you can see it's processing fine. So very simple solution for finding a cycle in a linked list. And yeah, this is a good technique to use. Understand this slow and fast technique, right? The two pointer approach in finding the cycle. And there are many more cases where you will be this approach will be useful. So understand this and learn, try to use this approach, right? Fast pointers versus slow pointers, and it will make fun to solve linked list problem. Thank you so much. One more thing, it uses, as you see, right, we are not using any storage like any inbuilt data structure, so that's a good, like we are in the space, we are working in the same memory space. So the space complexity is over. Amazing. Thank you so much.